Welcome to the first chapter in your study for CCNA 200-301. The CCNA is the new CCNA released on February 2020. This video begins Part 1, Introduction to Networking, which focuses on the basics of networking. This video is very important for beginners. You will have an extra information that will improve your understanding on network. I advise beginners to follow this video carefully, so take a notebook and write down. We will cover in this video, networking models, and exactly TCP/IP model. We will explain layers and protocols on TCP/IP model. We will explain very well this model and I will explain it in a simple way, so that everyone can understand. Bring your notebook and a pen and let's go. First, if I told you to give me a definition of network. What does network mean? Try to give me a definition. I give you a few seconds to think. Okay, a network is a set of rules, and details, and various devices, and software, that work together to do their job. That job is simply this, moving data from one device to another. I explain with an example to understand. Let's imagine that you are connected to the internet from your phone, or from your computer. And you are watching videos on YouTube or on Facebook. The cloud is a symbol meaning the internet. And in the internet, there are some equipment, for example, switches, routers. These equipment that we will detail later in the next videos. So the network is that, it is all the details, and the rules, and equipment, to send information from the source to the destination, from YouTube to your device. Okay? And, even you buy equipment from different manufacturer, for instance, HP, Nokia or Dell, there no impact on the network, because, they follow the same rule and the same networking model. I repeat the last sentence. Even if, you buy equipment from different manufacturers, for example HP, Nokia or Dell, there is no impact on the network, because, they follow the same rule and the same network model. Yes, the same network model. So what does network model mean? This is very important on CCNA. If you understand what the network model is, you will progress very well in our CCNA course. You can think of a networking model as you think of a set of architectural plans for building a house. A lot of different people work on building your house, such as framers, electricians, bricklayers, painters, and so on. The blueprint helps ensure that all the different pieces of the house work together as a whole. Similarly, the people who make networking products, and the people who use those products to build their own computer networks, follow a particular networking model. That networking model defines rules about how each part of the network should work, as well as how the parts should work together so that the entire network functions correctly. As I already said, we will detail two models on CCNA, TCP/IP model, and OC model. It's not complicated, I'll explain everything to you. First, let me give you an idea on how was the connection in the 1970s, in the years when network protocols did not exist, including TCP/IP. So, before 1970, each vendor created their own proprietary networking models. For instance, IBM company created own networking model, Dell company create own networking model. Therefore Dell computers cannot communicate with HP computers, and Nokia cannot connect to other brand computers directly. As a result, if your company bought computers from 3 vendors, network engineers often had to create 3 different networks, based on the networking models created by each company, making the combined networks much more complex. So the solution is to find an open, vendor-neutral networking model, that would aid competition, and reduce complexity, okay? So, the first solution is the OZZE model, created by the International Organization for Standardization, ISO, at the end of the 1970s. ISO had a noble goal for the OZZE model, to standardize data networking protocols, and to allow communication among all computers across the entire planet. After that, Department of Defense, DoD, and researchers at various universities volunteered to create another competing open networking model, called TCP/IP. So the second solution is TCP/IP model, okay? So, during the 1990s, companies began adding OZZE, TCP/IP, or both to their enterprise networks. However, by the end of the 1990s, TCP/IP had become the common choice, and OZZE model fell away because of a slower formal standardization process as compared with TCP/IP model. Look now at the second picture to see the general idea behind enterprise networks in that decade, still with multiple networking models but including TCP/IP. But after, all networking models been discarded in favor of TCP/IP. So TCP/IP has become the most prolific network model ever, as shown on third picture. Remember, the goal of this chapter is to help you understand what a networking model or networking architecture really is, and how it works. And because today, the world of computer networking uses one networking model, TCP/IP, so I will start by explaining the TCP/IP model. I'll give you a few seconds as a little break, and we'll continue. Okay, what is the TCP/IP model? The TCP/IP model defines and references a large collection of protocols that allow computers to communicate. Okay? I repeat. The TCP/IP model defines and references a large collection of protocols that allow computers to communicate. And these protocols are defined on documents called requests for comments, RFC. TCP/IP also avoids repeating work already done by some other standards or vendor by simply referring to standards or protocols created by those groups. For example, the Institute of Electrical and Electronic Engineers, I3E, defines protocol Ethernet for the local communication, so the TCP/IP model does not define Ethernet in RFCs, but refers to I3E Ethernet as an option. I will explain later I3E and Ethernet protocols, don't worry. So, the TCP/IP model creates a set of rules that allows us all to take a computer or mobile device, plug in all the right cables, turn it on, and connect to and use the network. You can use the web browser to connect to your favorite website like Facebook or YouTube. You can use most any app, and it all works. But how it work? Well, the OS and Ethernet card, or wireless LAN card, on the computer implement parts of the TCP/IP model. In short, the vendors that created the hardware and software implemented TCP/IP model. And to help people understand the networking model breaks the functions into a small number of categories, called layers. And each layer includes protocols and standards that relate to that category of functions, as shown in figure. Yes, this picture, as I said, networking model, breaks the functions into a small number of categories, called layers, and we have 5 layers on TCP/IP. Application layers, transport layer, network layer, data link layer, and physical layer. And each layer includes few protocols and standards. This allows us all to take a computer, or mobile device, and use the network, and use a web browser to connect to a favorite website like Facebook or YouTube. So, to understand how it works exactly, you should to understand each layer. And, as I said before, if you understand the network model, you will progress very well in CCNA course. Let's begin by explaining to you the application layer. The application layer provides an interface between software running on a computer and the network itself. The application layer, exactly, provides service to the application software running on a computer. Okay? So, the application layer tries to provide service to web browser, Firefox or Internet Explorer. You should understand that application layer does not define the application itself, but it defines services that applications need. So, the application layer is not the web browser, but is a protocol HTTP. I explain with example to better understand. Imagine that you open your browser, and you want to connect to Facebook. So you will initial request, by asking Facebook server, to send his home page. And Facebook server has been configured, to know the default web page is obtained in a file called home.htm. So you will receive the file from Facebook server. And the application layer on your laptop will use the protocol HTTP, which define how web browsers can pull the contents of a web page. Remember, that application layer does not define the application itself, but it defines services that applications need. For instance, the application layer is not web browser, but the application layer is the protocol that application need, which is HTTP. Another example. The application layer is not email, but the protocol IMAP or protocol POP3 used to read email. I will explain these protocol later, don't worry. So, that's all you need to know for the application layer in CCNA. Now, I'll give you a few seconds as a little break, and we'll continue. Now, we will detail the transport layer. The transport layer is responsible for end-to-end delivery of data from the source to destination. That's mean, transport layer is responsible for the logical communication between applications running on different hosts. That's why this layer is considered as host-to-host communication, or end-to-end. Transport layer includes a smaller number of protocols, TCP and UDP. TCP as Transmission Control Protocol, and UDP as User Datagram Protocol. You should also know that each layer provides a service to the layer above it. So, transport layer protocols provide services to the application layer protocols that reside one layer higher in the TCP/IP model. The question now: how does a transport layer protocol provide a service to a higher layer protocol? To answer, imagine I give you a spoon and an egg on top, and I ask you not to drop the egg. So you will walk slowly, taking care to not drop egg. Yes or no? So TCP is exactly same thing, slower, and it guarantees delivery of data. But UDP is the opposite. UDP is fast, and cannot guarantees deliver of data. UDP already used on voice over IP. Don't worry, I will explain TCP and UDP later. So, on network, many application layer protocols probably want a way to guarantee delivery of data across a network, so that people and service can get full information, without missing and dropping. For that reason, the creators of TCP included an error recovery feature, and to recover from errors, by using the concept of acknowledgements on TCP header. To better understand the concept of error recovery, look at this picture. Web server Facebook sending a web page to John web browser, using 3 separate messages. The TCP header shows a sequence numbered with each message. In this example, the network has a problem, and the network fails to deliver the TCP message with sequence number 2. When John receives messages with sequence numbers 1 and 3, but does not receive a message with sequence number 2, John realizes that message 2 was lost. That realization by John's TCP logic causes John to send a TCP segment back to Facebook server, asking Larry to send message 2 again. In summary, transport layer consists of the way to send the data, that means with error or without error, or in a fast way or not. Now, I'll give you a few seconds as a little break, and we'll continue. Now, what does mean network layer? Network layer includes a small number of protocols, but only one major protocol, already used, the Internet Protocol, IP. In fact, the name TCP/IP is simply the names of the 2 most common protocols, TCP and IP, separated by a slash. Network layer, using the IP protocol, provides a service of forwarding IP packets from one device to another. IP provides several features, most importantly, addressing and routing. Concerning addressing, IP defines that each host computer should have a different IP address. Like houses, each house must have a unique address. Concerning routing, IP created the necessary infrastructure to deliver data with device called routers. To better understand this layer, you can imagine that TCP IP application and transport layers act like the person sending letters, and network layer act like post office. So, the person sending the letter does not need to know the details of exactly what path the letters take, so the transport layer and application layer don't need to know anything more about the topology or the other routers. In contrast, the postal service does not create the letter, but it accepts the letter from the customer. So, the network layer must have the ability to deliver the letters with devices called router. And like I said before, each layer provides a service to the layer above it. So, the application layer and transport layer ask the layer below them, the network layer, to deliver the message. Okay. Now, the data link layer. It defines the protocols and hardware required to deliver data to next host, remember, next host or next router. That's mean, this layer defines details and rules to deliver data to next host, without cross the boundaries of a local area network. Data link layer is also responsible for converting data stream to signals, bit by bit, and to send that over the underlying hardware. Data link layer is also responsible at the receiving end, to picks up data from hardware, which are in the form of signals, assembles them in a recognizable frame format. Okay. The data link include a large number of protocols and standards. For example, all the variations of Ethernet protocols and wireless LAN protocols, discussed throughout this videos later, don't worry. Data link layer provides the means to detect, and possibly correct errors that can occur in the physical layer with FCS field. Don't worry, I will explain it next video. I will explain later Ethernet protocol and MAC addresses, okay? Don't worry. You should not forget that data link layer focus on sending data to next host, okay? Good. And finally, the physical layer. The physical layer defines the cabling and energy that flow over the cables, for example, electrical signals. This layer plays the role of interacting with actual hardware. You should know that this layer defines the hardware equipment, cabling, wiring, frequencies, pulses used to represent binary signals. We will soon detail later the different standards of the physical layer, and will detail the different cables, for example UTP cable and optical fiber, as well as how cables can send information. We have detailed the TCP/IP model and its different layers. To understand the role of each layer in a concrete way, imagine that the machine is connected with web browser to YouTube or Facebook. So, typically the machine uses HTTP or HTTPS protocol. I will try to show you the communication detail between a machine and the nearest router. Okay, so, first thing, the machine creates the data, then it will encapsulate it with HTTP header. Yes, you should know that every application data will be encapsulated with any required application layer header. For example, the HTTP OK message can be returned in an HTTP header. Remember the term encapsulation, that means each layer adds its own header. Next, encapsulate the data supplied by the application layer inside a transport layer header, TCP, or UDP header is typically used. And, this entity is called segment. I explained TCP and UDP, and you will soon have a video which explains TCP and UDP very well, because it is very important for CCNA. Next, encapsulate the data supplied by the transport layer or segment, inside a network layer header, typically IP, and this new entity is called packet, okay? Next, encapsulate the data supplied by the network layer, or packet, inside a data link layer header and trailer, and this entity called frame. Here you should notice that the data link layer adds the header and tail, okay? And finally, transmit the bits. The physical layer encodes a signal onto the medium to transmit the frame, So, now, if I ask you, what does encapsulation mean? Encapsulation refers to the process of putting headers and sometimes trailers, okay? Before ending this video, remember the name of messages. Each term has a specific meaning. For example, segment for the transport layer, packet for the network layer, and frame for the link layer. You should also know that at the reception, we do not encapsulation, but the unencapsulation. That mean, we remove that header and trailer. And, remember, that each layer provides a service to the layer above it. This is called adjacent layer interaction. And finally, there is some questions to check if you have understood correctly. Question number 1, which of the following protocols are examples of TCP IP transport layer protocols? Choose 2 answers. I'll give you a few seconds to answer. Okay, the correct answer is D and F. Yes, UDP and TCP. You remember, the transport layer includes a smaller number of protocols, TCP and UDP. TCP as Transmission Control Protocol, and UDP as User Datagram Protocol. Okay? So, Ethernet is false, because it is a data link layer protocol. HTTP and SMTP are false because they are an application layer protocol. IP is false because IP is a network layer protocol. Question 2, which of the following terms is used specifically to identify the entity created when encapsulating data inside data link layer headers and trailers? I'll give you a few seconds to answer. The correct answer is D. Yes, a frame. Like I said before, segment refer to the messages created on the transport layer, and packet for the network layer, and frame for the link layer, okay? Next, question 3, the process of a web server adding a TCP header to the contents of a web page, followed by adding an IP header and then adding a data link header and trailer, is an example of what? I'll give you a few seconds to answer. The correct answer is C, data encapsulation. Because, encapsulation refers to the process of putting headers and sometimes trailers, okay? So, that's all for the first video. If you have not answered these questions well, do not hesitate to watch the video again. And, wait for the second video soon, which will explain the ISA model and a lot of things on CCNA. If you have any questions or want me to explain this part in another language, leave a comment. Don't forget to subscribe to my channel and leave a like. See you soon.